right. Okay, so today we're going to start on basic differentiation rules. Okay, so far we've been describing our f prime of x as the limit f of x plus h minus f of x all over h as h approaches 0. Okay, so now we're going to do different types of notation.
Quick question.
Yes.
Do you know the grades for tests?
I'm like halfway done with them. I've done like all the way up to like problem 10, so I just have the last 6 to do. So they should be ready by tomorrow afternoon, tomorrow evening at the latest.
They'll be posted online.
Oh yeah, they'll be on Canvas, so you'll find out as soon as I'm done.
How are they looking?
I'll post the grades as soon as I don't want to say anything about anyone's grade. I'll post them as soon as they're graded.
We'll cross that bridge when we get there.
All right, so our f prime of x, which we know is our derivative of x. We also see that as the derivative with respect to x, or derivative of f with respect to x. Or you may also see it as derivative of f with respect to x. Bless you. Or let's say instead of x, we had t. So if we had our f prime of t, which would be the same as the derivative with respect to t of whatever f happens to be, which is the same as derivative of f with respect to t. So that last part just changes with the variable, with the independent variable. In the same way, you can have a g there be the derivative of g with respect to t or x or s or whichever variable they happen to be using. Okay. So now these are coming up are the shortcuts kind of to limits. They're kind of shortcuts, they're kind of not. But these are the ones most people have been waiting on. Leave that up for a little bit. Oh, thank you. All right. Okay, so the first one is the constant rule. Where it states the derivative of a constant is 0. Okay. Now that will be denoted as the derivative with respect to x of any constant is equal to 0. Okay, the derivative of 12, 20, whatever it is. Okay, so the proof of that, let's say if we let f of x equal c. Okay, so that means that f of x plus h There's no x to replace with x plus h, so that's also equal to c. Okay, so that means the limit f of x plus h, messed that one up. There you go. F of x plus h minus f of x all over h as h approaches 0 is equal to the limit as h approaches 0. Our f of x plus h is just a constant, minus our f of x, which is just a constant, all over h. So really you have the limit, any constant minus itself is just going to be 0. So the limit of 0, which is 0. Okay. So this is your proof. Yes.
Why did you say that wouldn't be indeterminate? Because.
Oh, because it's still over h. Because 0 over h is just going to be, because remember, 0, h is never 0. It's only approaching 0.
Gotcha.
Yeah, that makes sense?
Yep.
Okay. All right. Now, if they were both 0, then it would be indeterminate. All right. So let's say, for example, if you wanted to find, let's say if we let's say y equals 7. Then the derivative of y with respect to x would be 0. The derivative of any constant is just going to be 0. Okay, so let's say if we let f of x equal 9. Then f prime of x, which is the exact same thing, is just going to be 0. Okay. Let's say if we let s of t equal 3. Then s prime of t is going to equal 0. Okay. No matter what the constant is, it's just going to equal 0 each and every time, even if it's, let's say if we let f of t equal 4 pi squared. Since pi is just a constant, it's still going to equal 0. All right. So any questions on that one? All right.
Sorry.
Mhm.
The derivative of the y divided by the derivative of the x is the same thing as saying, like, f prime y? Or?
Yeah, so if we had, let's say if we made that instead of y, we decide to make that, you may see it a y, you may see y of x. So derivative of y with respect to x or derivative of y with respect to t, it doesn't matter what it's with respect to, it'll still be 0. Okay. So it would be the same thing if you plugged it into the limit formula. So the limit of, if you let f of x equal 7, then f of x plus h would still be 7. So if you plugged it in, it would always come out to be 0. This is just kind of a shortcut way of doing it. All right. Okay. So next, probably the one we'll use most often is the power rule. Okay. Okay. So let's say if we let f of x equal x to the power of n, where n is any real number. or any rational number. Okay. Okay, so that means x to the n give you derivative of f with respect to x will equal, you're going to bring your exponent down to the front. You have your variable, then you're going to subtract 1 from the exponent. Okay, this will be your power rule. Okay, now the proof of this one is pretty similar. You're going to let your f of x equal x to the n, which means your f of x plus h is going to equal x plus h to the power of n. Okay, so that means we have our limit of f of x plus h minus f of x all over h as h approaches 0. Okay, that's our derivative function. Okay, so that gives us the limit as h approaches 0 of x plus h to the n minus x to the power of n all over h. Okay, now we're going to use something called the binomial theorem for this one. Okay, so using the binomial theorem, where x plus h to the n, we know that's going to equal x to the n plus n x to the n minus 1 h plus n times n minus 1 x to the n minus 2 over 2 times h squared plus, and it keeps on going all the way till plus h squared minus x to the n. Oh, plus h squared. Skipped a step. Okay, so it's kind of like if you had x plus 3 to the 5th power. This is the formula that you would do all the way to 5. You probably didn't cover the binomial theorem yet. I think it comes in the end of Calc 2. But, no, actually it should come in trig. I don't think we cover it here, though. All right. So let's say if we just get this, well, this one, I guess, and plug it in. So the limit, h approaches 0 of n, should be x to the n. Clean that up a little bit more. There we go. X to the n plus n x to the n minus 1 h plus n times n minus 1 times x to the n minus 2 over 2 h squared plus all the way to h squared. Remember, that's just our x plus delta x to the n minus our f of x, which is h to the n, all over h. Oh, move that up a little bit.
You know, the dot, dot, dot.
Oh, it wouldn't be dot, dot, dot only because it ends at some point.
Okay.
Yep, so if it just kept going on forever, it would have the dot, dot, dot. But the dot, dot, dots in the middle just take up all the space of the ones we didn't put in. All right, so if we just simplify this, we would have the limit. Here we go. Oh, that one's not working. There we go. So we have the limit as h approaches 0 of x to the n plus nx to the n minus 1 h plus n times n minus 1 times x to the n minus 2 over 2 times h squared plus all the way to h squared minus x to the n all over h, where those two cancel out. Okay, so if we factored out at h from all of those, that should be a plus sign there, all of the terms in there, we have the limit as h approaches 0. We factor out of h here, we get our nx to the n minus 1 plus n times n minus 1 times x to the n minus 2 squared times h, since that one was h squared. Then you have n times n minus 1 times n minus 2 times x to the n minus 3 times h squared, and it just keeps on going and going and going. So it's plus all the way to h. And that's over h, where those two cancel out. Okay. Now, if you just use direct substitution and plug it in, then every term except that one would just become 0. Okay, so you actually end up with nx to the n minus 1, which is where the formula came from. All right. Any questions on that one? So as you can see, limits are kind of the backbone of this entire class. Oh, that's locked. All right. Oh, still writing. All right. Okay. So, using that, let's say when n equals 1, derivative of just x with respect to x is going to be 1. Oh, sorry about that. Okay. Because if you think about it, if you have, let's say, f of x equals x, then f prime of x using the power rule, say if you have x to the first power, you'd bring down that 1, x to the 1 minus 1, which is just x to the power of 0, which is 1. So derivative of any single variable is always going to be 1. All right, so let's say if you just, quick example of the power rule. I thought I had a couple of other examples. Here we go. Okay, so let's say for problem A, if we have f of x equals x to the third. Say for problem B, if we have g of x equals the cube root of x. And let's say for problem C, if we have y equals 1 over x squared. Okay, so we want to find the derivatives. Okay, so the solution for those, let's start with A and using the power rule. because there are a couple of different ways to solve them, but we're going to just use the power rule, especially for the last one. Okay, so for A, let's say we know that f prime of x is equal to, we're going to bring that 3 down to the front, and then we're going to subtract 1. Okay, so that's going to be, let me write the whole thing.
So you always subtract 1.
Yep, you always subtract 1 from the exponent. So f prime of x would equal 3x squared. Okay, now for b, sometimes you have to rewrite them. So we know that cube root of x is x to the 1/3 power. Okay, so even though you have to rewrite them, the steps are still the same. Okay, so that means f prime of x, you're going to bring that down to the front. So you have 1/3 x, and you're going to subtract 1. 1/3 minus 1. Okay, so doing that on the side. Oh, g prime, thank you. I know after a while you get used to writing f prime, f prime, f prime. All right, so after you get that, I'm just going to go ahead and add those on the side. 1/3 minus 1. So 1/3 minus 3/3 is equal to negative 2/3. So that means your g prime of x is going to equal 1/3 x to the negative 2/3. Or if you wanted to, you can take that negative 2/3 and put it in the denominator. All right. Any questions on those? All right. Okay. Now for C, we have, instead of y equals 1/x squared, we can make that y equals x to the negative 2 power. Okay, so derivative of y with respect to x is going to equal, we're going to bring that negative 2 out to the front, then we're going to subtract 1. Okay, so the derivative of y with respect to x is going to equal negative 2x to the negative 3. Or you can write it as negative 2/x to the 3rd. Same thing either way. Oh, bring that up some. All right, any questions on any of those? All right, so you're always just going to bring the exponent down, subtract it by 1.
So does the derivative version always have the -1, or is that the f prime? Or the prime?
Both of them, they're the same one.
Both of them
Yep.
will have the -1. in
Yep,
them?
both will have the -1. So if you have f prime of x or derivative of x, it's the exact same thing. You'll just see different notation.
It's like the first one, 3x, 3 minus 1, and you said that f prime of x is just 3x, 2.
Yep, 3x squared. Yep.
All right.
Yep, so we could have easily made that one, instead of f prime of x, we could have made it derivative of f with respect to x. And it still would have been 3x squared.
So what's the, I guess, what's the difference between derivative of f, derivative of x and f prime of x?
Not a thing.
Just different.
Yep, just different notation. It's actually about 5 or 6 different ways you can write the same thing. So sometimes you may see it as, let me see, derivative with respect to x. Sometimes you may see it as f prime of x. Sometimes you may see it as derivative with respect to x of f. Sometimes you may see it as derivative with respect to x. You'll see it you'll mostly see it this way in like Calc 3 and differential equations, stuff like that. But you'll see it every kind of way. But for the most part, we'll mainly do these and probably this one here and there. All right. So now we'll cover the constant multiple rule. Okay. Where the derivative with respect to x, let's say if we have our f of x and a constant multiplied to it. You can just pull that constant out to the front and differentiate the f of x. That's just going to be the constant times f prime of x. Okay, so of course, we have a proof. So derivative with respect to x of c times f of x. Remember, that's just going to be the limit as h approaches 0 of c times f of x plus h minus c times f of x all over h. You see here, you can just bring the c right out from the front, or right out to the front. The limit as h approaches 0 of c times f of x plus h minus f of x all over h. Okay. Now, if you remember from our limit properties, you can, when you have the limit of any two factors, you can just apply the limit to both of them. So you have the limit of c as h approaches 0 times the limit of f of x plus h minus f of x all over h as h approaches 0. So the limit of a constant is just that constant. And this is our f prime of x. So c times f prime of x. Okay, so everything has a proof. Even something as it looks like it will be, well, that's obvious. You just pull the constant out, but yep, there's a proof attached to it. All right, so, oh, that's right, let me see. Also, let's say if you had the derivative with respect to x of some f of x over the constant, if it's just divided by. Okay, so if you wanted to, you can make that derivative with respect to x of 1 over c times f of x. And you can just bring that fraction, or that constant fraction rather, derivative of f prime of x. I guess I could have left that in there. Which is 1 over c times f prime of x. Even though 1 over c is still a constant, even if it's a fraction, you can just pull it right out to the front. Excuse me. All right, so let's say, for example, if we have, let's say, find the derivative of, let's say for problem A,